Hi everyone, my name is ZHERN Liang. Today, I'm going to talk about my engineering quality control assignment. This presentation is separated into 6 sections, includes introductions, control charts, process capability charts, ANOVA, comparisons, and conclusions. A sustainable development goal named Responsible Consumption and Production seeks to minimize waste and guarantee the effective use of resources during the production process. In order to assist industry improve their production process and promote more sustainable patterns of consumption and production, statistical process control is a quality tool. R is a programming language and free software environment which is frequently used for statistical computing and graphics. In this assignment, the data of 3 different machines are given in terms of timestamp, temperature, pressure, part length, part resistance in the form of table, and R software is used to compute this data. The end of this assignment is to draw appropriate charts by using R software and make conclusions based on the provided data. Firstly, we are going to discuss about the control charts for 3 machines. For machine 1, we can see that all the subgroups are fall between the upper control limits and lower control limits, and there is no outliers present. Therefore, the process is in control. The control chart for machine 2 shows an outlier fall outside the lower control limits, hence the process is out of control. The same conditions is shown by the control chart for machine 3. One outliers fall outside the lower control limits, hence the process for machine 3 is also out of control. Next, we are going to talk about the process capability charts. By referring to the process capability chart for machine 1, the mean is 49.89754 and the standard deviation is 0.592164. The process capability index CP and CPK for machine 1 is 2.81 and 2.76, which is greater than 1.33 and 1 respectively. Therefore, machine 1 meets the specifications. For machine 2, the mean is 48.6473 and standard deviation is 1.056617. For process capability index, CP for machine 2 is 1.58, which is greater than 1.33, and the CPK is 1.15, which is greater than 1. Hence, machine 2 also meets specifications. The mean and standard deviation for machine 3 is 51.925337 and 0.65001515 respectively. The CP for machine 3, which is greater than 1.33, is 2.56 and the CPK is 1.58, which is greater than 1. Therefore, machine 3 also meets specification. Now, we are going to talk about the analysis of variance, ANOVA. Whenever PR greater than F value is smaller than alpha, the factor is considered significant. We assume alpha equals to 0.05. Since the value which is smaller than 2 exponential to the power of negative 16 is too small, therefore, it is considered to be 0. For machine 1, 2, and 3, resistance PR greater than F value for the pressure and temperature is 0, which is smaller than 0.05. Therefore, pressure and temperature are both significant factors for all 3 machines. For machines 1 and 2, resistance PR greater than F value for the pressure times temperature is 0.698 and 0.799 respectively. Both of the values are greater than 0.05. Hence, factor pressure times temperature is not significant for machine 1 and 2. However, the factor pressure times temperature is significant for machine 3 as resistance PR greater than F value for the pressure times temperature of machine 3 is 0.00303 which is smaller than 0.05. Here is the comparison between the block spots of three machines. From here, we can see that the block spots are almost similar. All of the mean temperature decreased when hot resistance increased. There are outliers present for temperature 303 Kelvin and 373 Kelvin. But when it comes to temperature of 338 Kelvin, there is no outliers. Hence, hot resistance for temperature 338 Kelvin is the most consistent. Now, we are going to compare these three machines based on the data we analyzed before. From the slideshow, we can see that process in control only happen in machine 1. The process for machine 2 and 3 are out of control with one outlier each. All three machines are capable and meet the specifications by referring to their CP and CPK values. For machine 1 and 2, pressure and temperature are both significant factors, while pressure times temperature is not. Meanwhile, pressure, temperature, and pressure times temperature factors are all significant for machine 3. In conclusion, machine 1 is the best option to be recommended. The reason behind this is that machine 1 is the only machine that shows control process under the control chart. For industry, the minimum process capability index is usually established at 1.33. The higher the process capability index, the better the quality. The process capability index for machine 1, which is CP is equal to 2.81 and CPK equals to 2.76. The process capability index for machine 1 is CP equal to 2.81 and CPK equals to 2.76, which both greater than 1.33 and 1 respectively, and they are highest among these three machines. In other words, machine 1 has exceeds the basic requirements. Moreover, standard deviation for machine 1 is 0.592164, which is smallest among three machines. Hence, we can say that machine 1 undergoes the most consistent process. When it comes to analysis of variance ANOVA, only pressure times temperature factor are not significant, but pressure and temperature are both significant factors for machine 1. That's all for my presentations. Thank you.